All right, y'all, check out number 3. Now, this looks overwhelming at first, and you're like, oh my God, mister, it's too much. But remember the rules we learned. Remember the rules we learned on the last unit. This is why they matter so much. Check out what I'm going to do. I don't like operating with these houses. These radicals, I don't like radicals. I'm going to change it into this. Watch what I do. This is the denominator. That 2 ends up being the denominator. And that 3 ends up being the numerator, equal to 8. All I did on this first step is I rewrote it. That's all I did. I just rewrote it. I changed out of this into exponent form, from radical form to exponent form. Mathematically, they mean the same thing, but I think as humans, this is easier to work with. So I'm going to go ahead and switch my pen ink now. And now we can see I have x minus 2 raised to the power of 3 halves. Well, I'm going to use the rule, the exponent rule, and I'm going to raise this up to 2/3 because it's the inverse. If I do it on one side, I must do it on the other side. That's the rule. Make sure you show your work. Again, I am way more interested in the process than I am the actual answer. When I do this, 3 times 2 over 2 times 3, that reduces down to 1. So that frees up this x minus 2. This all cancels out now. This basically cancels out with it. You can let go of these parentheses. All this just disappears and goes away, and you're left with x minus 2. And then you're left with 8 to the 2/3. Now, again, I'm going to be cool with y'all typing this into Desmos. I don't know if Algebra 3 people are going to let you type this exact number into the calculator, but I am cool. As long as you show the steps, make sure you do it. But for those who are interested, here's how you solve this little part. Are you ready to see this? For 8, I can go to Desmos and type in 8 raised to the power of 2 divided by 3. And it gives me the answer of 4. All right? So I know that it's 4, but check this out. I'm going to go over here and I'm going to show you something. So if I have 8 raised to the power of 2/3, I'm going to put the cube here. I'm going to put the cube here because that's the denominator, and then that square is going to go up here. So now check it out. Now I have the cube root of 8 squared is 64, and then the cube root of 64 is 4. So you technically do not need a calculator to actually solve this problem right here. These are small enough numbers, and we've worked with them enough, you can solve it. So this comes out to 4. So when I evaluate this thing, I end up with x minus 2 equals 4. Now I'm going to add 2 on both sides. I'm going to add 2 on both sides, and I get x equals 6. And this is, theoretically, my answer. I'd have to go in and plug it into Desmos to see if this is the case, which, let's do it right now. All right, remember you go to the functions thing, go all the way down to this sucker right here. We have 2 and 3, so we have a 2 here, and then we're going to have our body inside here, and then we have the 3 right here. So we have that set up for ourselves, so that's good. It's x minus 2 that goes in here, x minus 2, and we're trying to get it to equal 8. We're trying to get it to equal 8. So where does it equal 8 at? Right there. It's at 6. So when that line shows up, it's at 6. So let's go ahead. I'm going to copy this. I'm going to do it here. And what did my answer come out to? My answer did, in fact, come out to 6. So I'm going to replace my x with that 6. And I'm going to see what this evaluates to. And the answer is, in fact, 8. So you can graph it, the whole equation, and then go check it and see where the answer comes up. Or you can actually plug in your answer and pull it out this way. And there you have it. So this is actually a solution. So this is a solution. It's not an extraneous, it's a solution. Awesome. Next one. Nope, I'll do this in a separate video.